Hello everyone. So today we are going to do revision on the next chapter, that is force and laws of motion. So under that first question it is define force. That is first thing we have to learn is what is force and what are the types of force. Force is nothing but it is a push or a pull on an object that produces acceleration in the body. That means when you are going to say a force is acted upon an object means when we are going to do push, when you are going to push that object or when you are going to pull that object, we are going to say the force is acted upon on that object. So and also SI unit of force is Newton. It is also denoted by capital letter N here, and also force is a vector quantity. So we have known that what is vector and scalar quantity. So since force depends upon both magnitude, that means the value, and also direction, hence force is a vector quantity. Similarly, what are the types of forces is also given the question. So what are the types of force? One is balanced force and another one is unbalanced force. So balanced force means when force acts on an object from opposite direction that do not change the state of rest or motion of the object. So for this, if we give the example of a box, so one box is there. For instance, a person here you will be standing and another one person, your friend, will be standing in opposite direction. You are applying, for example, 5 Newton of force you are applying. Similarly, your friend is also applying 5 Newton of force. So you are pushing that object, that fellow is also pushing that object. If both the forces, you can see both the forces are same, that means both of you are applying the same magnitude of force but in a opposite direction, isn't it? This you are applying in this direction with the same magnitude. This your friend is also applying the force with the same magnitude but in a opposite direction. When there is an equal amount of force which is acting on an object in an opposite direction, in that cases this object do not move, isn't it? It remains in a rest position itself. This type of force where there is no change in position of the object, that means there is no change in state of rest or a motion of object, this type of force is called as balanced force. Next is unbalanced force. So same example I'll consider. So a box is there and you're applying 5 Newton of force and your friend is applying some 3 Newton of force. Okay. Here when two opposite forces acting on a body moves a body in the direction of greater force is called it as the unbalanced force. So here who is applying the greater force? So you are applying greater force of 5 Newton compared to your friend. So where this object will move, the object will move in this direction. That means the force which is greater in that direction, that object will be moving. That means this is called as unbalanced force. Next is, so only we are going to say only if there is a types of forces means only you are saying about the balanced and unbalanced force. We are not saying about frictional force, but this is just an additional one. So what is this frictional force means, or the friction? Force which is always opposes the motion of the object. So whenever the best example for the frictional force is ball. When the ball is rolling on the ground, suddenly after a few minutes that ball will stop. Why that ball will stop? Because there is a frictional force which is acting on that object. Because of that there is a change in motion of the object. Next is a very important topic. What is inertia? Explain the types of inertia. So what is this inertia means? The tendency of an object to remain in state of rest or in a motion. That means the object, for example, you're sitting means you will remain in that position itself unless an external force is acted upon on it, isn't it? When the ball is rolling on the ground, it remains in rolling on the ground unless an external force is applied on it. External force, I can say it frictional force also. That are the examples we can give for an inertia. The inertia, or it is the tendency of the object or the body to remain in a rest position or in a motion position unless any of the external force is acted upon on it. Okay, this is a very important topic. Based on this, there are three types of inertia are there. So one is inertia at rest. So for this types of inertia to understand, so let us give one example. Based on that example, we'll go with the inertia at rest or inertia of motion or inertia of the direction. So for example, for the inertia, we'll give of a bus. So how we are going to say types of inertia by giving an example of a bus means inertia of rest. What is this inertia of rest means? The object remain at rest unless acted upon by an external force. That means when a bus is at rest position, it will remain in a rest position unless acted upon by external force. Unless acted upon by external force means before starting that bus or any vehicle, if you consider, it remain in rest unless there is an external force is applied on it. Without applying the external force, at a time it only don't go or it only does not change its position. Similarly, the next one is inertia of motion. So for example, say that is a bus, if you have considered, the bus remains in its motion position unless a brake is applied. If the brake is applied, the object remain in motion unless acted upon by external force. The object remains in motion unless brake is applied. When the brake is applied, then the motion position is changing into the rest position. That is called as inertia of motion. Next, third one is inertia of direction. So what is inertia of direction means? Same bus we will consider. The bus remains in a straight line. For example, the road is straight road is there. The bus will remain in this direction itself unless you have made a U-turn. In that direction, in that position, the direction of the bus will changes. So this is called the inertia of direction. In all these cases, inertia of direction, inertia of motion, inertia of rest, our body, the tendency of our body will object. That means it does not help for the motion, isn't it? Direction of inertia of direction means when you are moving in a straight line, suddenly when there is a turn has taken, your body does not support to that change, isn't it? Why does your body does not support? Because your body is having some inertia. That inertia does not allow. So for few seconds, your body will jerk towards the previous position. That is why it is called as inertia. Okay. Next question is, what is momentum? Momentum is equal to the product of mass and velocity of the body. So any of the body, if you have considered, if the body is having some mass and velocity, that means only when an object is moving. Velocity term will come only when there is a motion is there. So when an object is moving, then only you are saying that object will be having the momentum, isn't it? So mass, the object obviously will be having the mass, and the velocity, the object which is moving will be having some mass. That mass and velocity product is nothing but the momentum. So momentum is a vector quantity and it is unit is kg meter per second. Okay. Next, very important thing. So chapter itself states that is force and Newton laws of motion. So first we have to know what are the three laws of motion that Newton has predicted. So first, under the Newton first law says, Newton first law is also called it as law of inertia. That means an object remain in a rest or in a motion. The object remain in a state of rest or in a motion unless acted upon in a straight line, unless acted upon by an external unbalanced force. So the object will remain in a rest or in a motion unless an external unbalanced force is applied on it. So you can give the example for the Newton first law, same example as inertia what you will give, same example you can give for the Newton first law. Newton's second law says the rate of change of momentum of object is directly proportional to applied unbalanced force in the direction of force. So the formula here is F is equals to ma. So why it is F is equals to ma and what is this definition means? It definition says force is directly proportional to the rate of change of momentum. Momentum, you know what is the formula for the momentum? mv, isn't it? So, and rate of change of momentum is given. Change of momentum is nothing but there is a change in momentum. Rate is nothing but divide by time, isn't it? So rate of change of momentum is directly proportional to the applied unbalanced force in the direction of the force. So you have known what is the rate of change of momentum is nothing but mv minus u by t. What does this v minus u divide by t represent? It represents a. So I can write it as, so in general I can write F is equals to ma. This is the formula for the Newton's second law of motion. So for this example, you can give as a ball catched by the bowler, okay, or a fielder catching the ball. So the ball which will be coming will be having some momentum, isn't it? The ball will be having the mass and it will be moving with some velocity. When the bowler or the fielder catches the ball, in that cases the fielder has to apply a force, isn't it? There will be some momentum for the ball. Momentum means mass and velocity for that ball. To stop that momentum or to change that force or to change that momentum, the bowler or the fielder has to apply a force on it. When the force is applied, he has to apply more force to overcome that momentum. So in that cases, there will be a pain, or he has to apply the more force in the direction of the force here. Okay, that is the example we can give for the Newton's second law. Next, Newton's third law states that for every action there is a equal and opposite reaction. So when we throw the ball onto the wall, so with the same force that ball will comes in an opposite direction. So that is an example we can give for the Newton's third law.